Hey everybody, welcome to week 8 of 3D Basics. Today's lecture is a little bit less about creating things in 3D and a lot more about rendering here in Blender. So we'll look at a few different aspects of rendering, but basically just like what is even happening when you render. First, we will look at how to render animations, since this is a part of your assignment 4, is rendering out a 10-second video or a 10-second animation. And then we'll look a little bit more about the Cycles render engine, and we'll talk a little bit more about how computer hardware, how the different parts of your computer can improve your renders by making them look better or making it happen faster. So let's jump right in. So first, we'll talk about rendering an animation. So of course I need an animation. I am going to I want my animation to only be 60 frames because I want this to be a pretty short example. So remember, there's a couple ways to change the duration of the animation. First is if we are in the timeline editor, in our layout view here, we can see the timeline on the bottom. Timeline editor is signaled by the little clock here. We have start frame and end frame. So right now it's at 250. I'm going to change this to 60. So we start on frame 1 and end on frame 60. The length is 60 frames. Up here in your output properties, you have the little printer. This is another place where we can change your frame start, frame end, and probably more importantly, your frame rate, which doesn't necessarily make a difference here. Well, it will make a difference for the playback speed. If you press the spacebar to play your animation, it's going to play 24 frames every second. But if you're taking this into another editing software, Premiere, After Effects, something like that, you can set your frame rate there as well. But I will change this to 30 frames. So this is a 2-second animation. Okay, so now to animate. I'm going to go to frame 1. I want to I'm going to hit I to keyframe location, rotation, scale. And then I'm going to just like G, move it over here, R, rotate it like this, and S, scale it like this. Oops. And of course, I did not move off my frame, so I won't be able to keyframe again. So now let me go to frame 60 and do that exact same thing. G, move it here, R, rotate, S, scale, and then I'll hit I for insert keyframe, and I will do available. And so now we have a 60-second animation. I'll do one more thing just for fun. I showed you this example before, but I'm going to also keyframe the material that's on my cube by changing the color. Actually, why don't I change the metallic this time? So I'll keyframe my metallic value here on frame 1. I'll go forward to frame 60 and then just up the metallic to 100% and keyframe there. Because I'm not in material preview or render preview, we're not seeing that, so I'll hit Z. And I'll do render preview like this, so we can see that it's changing from light to dark. Maybe I'll also do the base color. We'll go white to, pink. Now it's pink metal. All right, here's our animation. Also, we want to make sure that our camera can see what's happening. Because when you render, you must have a camera in your scene. So what's actually handy about the animation workspace here is that it offers you a window of, move my camera somewhere better. We have a window on the left here of what your camera is seeing, in addition to your regular kind of workspace here. So as I scrub through this, we can see that it kind of goes out of view a little bit. Let me change these to rendered so we can see it happening too. So here's your bonus tip. Let's just have the camera have it look at the cube as it goes. Now, we could animate the camera itself. We could animate the rotation to just try to get it right. But there's actually a way to tell the camera to always be looking at this cube. So let's see how to do that. So clicking on our camera, we have let's see, which one is it here? Object constraint properties. We haven't looked at this one yet. It's this little like kind of looks like an eyeball or something. But let's add an object constraint to this one. If you click this drop down, there's a few options, and the one we want to look at is track to. So go ahead and click that and add it on here. And what this will do, or what we need to do, is assign a target to this object constraint, and it's going to look at that object the whole time, track to it. So if you can hit the eyedropper here, and I'm just going to eyedrop cube, and you can see that now if we preview our animation, the camera is going to look at it the whole time. So that's kind of cool. So yeah, this is what the camera is seeing over here, and this is our regular viewport. So if you watch the camera, you can see that as I scrub through, the camera's turning to follow the cube. Cool. Okay, so we have an animation. How do we render an animation? So previously what we've done is we've gone to render and render image, and it gives us a single image that we can save or whatever. But let's look at our animation or our output properties a little bit closer. So some important considerations here. Now, of course, my camera's in the way again. Go over here. Resolution X, resolution Y, 1920 pixels by 1080. This is considered full HD. This is probably the size of your screen on your TV or on your computer monitor. Obviously, there are screens that are larger than this. There's 4K TVs and 2K monitors and things like that. But this is like a good standard HD video size, 1920 pixels in the X direction and 1080 in the Y direction. We've already set our frame rate and our frame start and end. Let's look at output here. Lots of things to look at. The first and probably one of the more important things to look at is where your outputs are going. So you may not realize this, but every time you are hitting render, it's going into this temp folder on your computer somewhere. So let's actually make a nice new place for our render to go. So hit the little folder icon here, and I'm going to make a new folder in my spring 2022 folder, and I'm going to make a new one in here, and I'm going to call this animations. You can call it whatever you want. And then within animations, I'm going to actually make a new folder, and I'm going to call this, let's make a new folder. I'm going to call this Cube Twist. Cool. And then I'm going to open that one up and accept. So I've made a new folder called Cube Twist that I am accepting here. So we can see that, I'm on my D drive, Hennepin Text, String 2022, animations, and then Cube Twist. Saving file extensions, yeah, that's fine. Okay, file format. Here's a biggie. Open this and see what options we have. There are several image options. Oops, and there are also a couple of movie. It says movie options, but I prefer the term video. These are video file options. So let's see what happens. First, I'm gonna select a video format. So I'm gonna do FFmpeg video. So if you're on a Mac or if you're like using something else, you may have different options here. FFmpeg video is more of a standard-ish format, we'll say. To roll down encoding here. Now, like I'm a video nerd, so like this, I'm a video professional, so these kinds of settings I know way too much about. But it's important to at least know that these are here. So container, Matroska. So this is like a .mkv file, so that you're choosing like the file type that it's going to render to. AVI, QuickTime, Flash, WebM, whatever. QuickTime probably works for most, so let's just do that. Codec, H.264. H.264 is compressed, so you'll experience some quality loss if you do H.264, but it'll be like a much smaller file size, a little bit more manageable. And like probably a fine place to start. Like DNX is like and again, I'm getting into the weeds a little bit, but like DNX is like a 10-bit equivalent of what's it called? ProRes. WebM, Theora, like these are like pretty low quality compressed web video format stuff as well. Flash is like some of these are dated, but probably if you're rendering out a video file, do H.264. You can select quality, medium quality, whatever is fine, encoding speed, whatever, fine. So this is a way to do it, and in a moment I'll tell you why rendering out a video file is not the best way to do it. But let's just follow this through so you can see how it works. So now I've got so this has no audio too. I mean, there's a few other things we can do, but this is fine. So I've located my folder. I've determined the file format. I've determined I want it to be in a QuickTime container, which is an MOV. Video codec, I've chosen 8.264, which is compressed, but fine. Medium quality, or we can even do high quality, sure, because this is a very basic animation. Encoding speed, good. Slowest real time, whatever. And now we can go up to our render menu and do render animation. And you'll see it now kind of play as it renders each frame. And because it's only 60 frames, it should be only a moment until it is complete. Done. Okay, so it did it. We can see that it finished. It's at the end of the animation, but you just have to go find it now. So like, let's go to my Spring 2022, go to my animations folder, go to Cube, Twist, and here now I have this file. This video file. It is named 0001-00600, which of course is the number of frames, and I can loop this actually when I loop this and play it a few times. So now this is a video file of our rendered animation. It's 2 seconds long because it is 60 frames at 30 frames per second. Cool. So that is one way to render an animation. Now, I will caution you to do it this way. The more efficient way, well, and maybe efficient isn't the correct word, but the safer way and the way that most people render animations is one frame at a time. And not at a time, but render an image sequence. So let's talk about how that works. So going back to Blender, closing my animation here. The other thing too, whoops, boing. The other thing too, the file name is so like we could assign the file name here too. Like I could have typed in like so anything else like woof 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 woof, and it would have done that and then appended the 001-06006, whatever the numbers. That has something to do with our preferences. Save and load. It's somewhere in here where you can change what it is changing the file name to, or what it appends the file name. But honestly, like you can always, as long as you know where it's being saved, you can change it after the fact. So I usually just keep it as is. Now, the other where was I? Image sequence. The other way to do it, and the way I would recommend doing it, is rather than doing a file format, do an image format. So like, hopefully you recognize some of these: JPEG, PNG, Targa. Some of these are like much heavier image formats, like Targa, I believe is like or no, it's TIFF. TIFF is like a layered file that can be pretty large file sizes. For me, honestly, PNG is the one that I go for the most. And like you can pretty much keep everything the same. But why don't I even add No, I'm gonna add a little bit to the end of my file format here. I'm gonna just call this image sequence imgsec imsec, and you'll see what this does. Okay, so with the PNG file format, we've got a few different options now. Black and white for color, red, green, blue alpha. We'll talk about alpha in a little bit, but RGB is fine. Color depth, you can do an 8-bit depth or a 16-bit depth. Again, like if you're going for really high quality and you have lots of different colors, you want a little bit more color depth, you can choose 16 or 8. Compression, the amount of compression, let's just do 0. We don't want it to be compressed at all. And let's see what this does. So I added this title imgseq just so you can see the effect. So now let's just do it. Render animation. And so you can see that now again, where it's up here in the top left, we can see which frame it's rendering, frame 32, 33, 34. So we're nearly there. And it is done. So let's go let's go open up our folder. Spring 2022, animations, cube twist. Aha. Okay. So take a look at what we've got here. So now we have 60 PNGs in here. So there's one, there's this one, and it's named, and hopefully you can see it on my tiny screen, but like the name of these is imgseq, so like what I added to the end here, and then 0001, 0002. So it's like the name I gave it, and then it adds which frame it is at the end. So this is called an image sequence. I'm actually going to delete my video file. So I just have my 60 images in here. Now, why is this better? Let's say you have an animation that is wild, and it's got tons of cool models, lots of great materials and textures, and you're using the cycles renderer, and it's going to take 10 hours to render. Then imagine, and so it's like you do it at night, you set it to render, and you go to sleep. And then in the middle of the night, when it's 8 hours and 59 minutes along, your power goes out. And you have now lost that render. The 8 hours of rendering is gone, because when you're writing to a video file, it's like all or nothing. Either it all makes it in, or it cuts off halfway through and you have a corrupt video file. So rather, if you had done it like this, where you're rendering an image sequence and it's doing one at a time, you would have the first 90% of those done. And so then when you get your power back on, fire it up again, you'd only need to render the last few. So that's a reason to do an image sequence. Also, let's say you have like a long action sequence with different angles, and it's like, okay, like the first part is like like a shot of this guy, and then it's a reaction shot of this guy, and he throws this punch and do whatever. And so imagine like you get all the way through that, and later you say, you know what, I want to change just this part in the middle, this one shot. Or maybe like there's a little bit of the animation where you can see, I want to change the color of somebody's shirt or something like that. So then again, rather than having to re-render the whole thing, you only need to re-render the ones that you want to change. It's like, okay, I only want to change these 8 frames right here. And then you only need to render those 8 frames. So then you can say, hey, instead of all 60 frames, I just want to start at frame 50. So re-render 50 to 60, and overwrite my image sequence here, I can do it again, render animation, and it'll just redo those last 10 frames and overwrite them here. So it's like, oh yeah, so then these ones here are the fresh new ones with the change. So that's 2 reasons. A third reason that I just thought of, so like Disney, imagine the latest Disney Pixar movie, Encanto. Have you seen it? It's great. They have, like, imagine the amount of computing power it takes to render one of those frames. Like, just beautiful models and scenery and like animations and text, like really great stuff. And they're doing it, I'm sure they're doing it like in 4K so that, like, you know, you can get the Ultra HD DVD someday. So it probably takes hours to render one frame. So if you were to do it on one computer, you know, imagine how many frames are in a feature-length film, you know, thousands, tens of thousands, times hours is tens of thousands of hours. You know, that's not very efficient. It's going to take longer to render than it is to actually like animate the movie. So they spread it out amongst several hundred likely computers. So like they'll take the same project or the same file and say like, okay, this computer, you render the first 2 frames. This computer, you render the next 2 frames. So like if you're in the lab at Hennepin Tech and you got a big animation, and it's like, oh no, it's due by midnight and I don't have time to render. Just copy your file onto 4 or 5 machines and say, okay, this computer, you render the first 10 frames. This computer, you render the next 10. And so like they call it render farming. So you can like have a farm of computers all rendering different parts of your assignment. And then at the end, you take all the files and then put them together. So let's talk about now how you would put this together. Now, it's important to have them all together in the same folder, preferably, and then have nothing else in the folder. So like I've got animation, my animations folder, and then this is called Cube Twist with this render in it. If I were to do it again, I might make a new folder in here, Control Shift N, and call this like Cube Twist 2. So like I'd have the different renders in different folders. So this one folder holds all the renders, or all of the image sequence, and only the image sequence. It is also important that they're numbered. So that's why, you know, Blender will automatically do it, but you need them to be numbered so that like whatever program you're using to compile them knows that this is a sequence of images. So you can, like, if you know After Effects, you can bring an image sequence into After Effects and it'll treat it like a video file, basically. But there's also a way in Blender. So this is a Blender class, so I'll show you the Blender way to do it. Okay, let me go back to Blender. Let me close our render view here. Let's go back to layout mode. Up here, so up next to where we have object mode, where it says object mode, next to this, like right below the little Blender icon, there's like this little hashtag with a thing on it. Let's go down to under the general, we want video sequencer. And what this is going to do is it is going to turn your sequence into a video. All right, so here now in our sequencer, we're going to go to the add menu and we want to add image/sequence, image sequence. And, oh, look, it already kind of found what was going on here. So we've got our cube twist here. And we want to, let's see, start frame 1, end frame is 60. And do I have to select all? Do I do A like this and do add image strip? Will this work? I think that did it. And then from here, it's just a matter of rendering it out again. So over here on the right, we have, change it to a movie format, FFmpeg video, change the container to QuickTime or whatever. Video codec, H.264 is fine. Output quality, let's change that to high quality. Speed, good, sure. And then we go back to the render menu up here and render animation. And you can see that time now it goes a lot faster. And it actually looks like it did it backwards for some reason. Let's look at that. Yeah, okay, so, interesting. Let's try this again. Let's delete this. I must have imported it wrong. So let's add image sequence. Let's sort by name, because maybe that makes a difference. Start frame, start with 1, please. End frame is 60. Because it seemed like they were all like out of order. So let me then select here like this. Add image strip. Let's see what this does. Let me try this again. High quality, good. Yep. Render animation. Okay. This looked like it did better. There we go. So it did matter which way it was brought in, because for whatever reason it was like jumping around. Okay, there it is. And hopefully you noticed that went a lot quicker, because rather than having to like actually calculate all of the 3D happenings, all it's doing is just smashing all those images together. So that's what you would do at the end if you had rendered it out as an image sequence. So then we've got, the video file here, img6q001, etc. And so then, you could upload this video file to D2L as part of your assignment 4. So, there's other ways to do it too. Like I think I mentioned this already, but if you use After Effects or Premiere or whatever, you've got a system. You can bring an image sequence into those video editors as well, but it can be done in Blender too. So just a reminder. So when you're in Blender, up here top left, video sequencer. This would be empty. Go to your add image sequence, find the folder. So that here's my Cube Twist folder. Sort by name so that they're in numerical order. So like, select 1 first and then go down, hold down the shift key and then select the last one. And then you can set your frame start and frame end. So it's from 1 to 60. 60. And then from here, you render your animation as you would otherwise with a video file. Cool. So that's how you render an animation. Now, let's talk about some boring stuff. How about? It's not boring to me. I'm a computer hardware nerd. So this is actually kind of exciting to me. Your computer your computer / laptop has a processor, and it may or may not have a graphics card, a GPU, a graphical. What does GPU stand for? I just called myself a computer hardware nerd. Graphical processing unit. Graphics processing unit. I called myself a computer hardware nerd, and then I don't know what GPU stands for. Anyway, some computers combine the two. So they call it a discrete graphics, where your processor also computes your graphics. So if you have a little bit fancier laptop or you have a desktop computer, it very likely has a graphics card or a GPU. And like if you play video games or things like that, you likely have a GPU that does those kinds of computing things for you. So it's calculating the polygons, where they go, and what they look like, which does require a fair amount of computing power. So some people will spend lots and lots of money on very nice graphics cards for gaming or potentially for 3D rendering, which are not too dissimilar. because it can do things faster and better. So like, the term you may hear is ray tracing. And we'll talk about this a little bit more as when we look at cycles. But like ray tracing is actually like taking light sources in your scene. I'm pointing at the light in my room. Taking light sources, calculating the rays, tracing the rays, ray tracing, to where they hit objects, and doing math and figuring out what it looks like. Now, Blender actually has very recently released an update, Blender 3.0, that has done some fancy math and computing work behind the scenes to make cycles even more exciting. So if you know you have a graphics card in your computer, maybe you even know what it is, what brand it is. There's been a shortage in the world the last couple of years since COVID started. There are ways to tell Blender to use your graphics card to help your renders look cooler, look better. So right now I'm going to model like something super duper quick and use cycles to do it. And we'll talk about like how to use cycles to make like really cool photorealistic renders. So back in Blender. Go back to my 3D viewport. Let's do a new general file. Don't save. Okay, let's think about this. One thing that I feel like I see 3D renders of all the time is like phones, smartphones. You'll see like a phone on like a totally white, cool backdrop, and it's like flipping around. For some reason, like I feel like Samsung does ads like that. So real fast, I'm gonna make I'm gonna model a phone, a smartphone. So first, I sometimes I like to render in not render. Sometimes I like to model in render preview just to kind of get a feel for it a little bit. So I will fast forward as I model this smartphone. Okay, here we go. So, that took me, 10 minutes or so to get the shape I wanted, but also to like, I had some materials on here. So it's just got like a shiny front and like kind of a silvery shiny back. And now I'm already seeing that like my corners are not like super nice right around here, but that's fine. Now, the other thing about having nice kind of complete renders is like having a background. Now, like by default, you've got this gray background, and it is casting like a gray light on your scene here. And like you could change the background. We'll talk about using HDRIs in a little bit. So actually, you can see in my material preview, it's got this like a built-in kind of reflection HDRI in here, so you can see there's actually like some trees and sky. It's just throwing those in as kind of like a reference to how shiny things are. If we were to go to render preview here, you could see that it's just reflecting the gray world. But one thing that is actually, we'll stay on material preview. One thing that you can do that's really easy is to just kind of create an infinite white backdrop without having to change all this. Is just, imagine getting your school picture taken and they had a seamless. So it was like a piece of cloth that was up on, some stands, and it like came down, and then it was like a 90-degree curve, and then you were standing on it. So we can kind of create a similar thing here. So I'm going to name this phone, and I'll GZ move this up, and let's do Shift A. I'm going to add a plane, and so we can scale this up pretty big. Then we can go tab for edit mode. Let's do 2 for edge select. I'm just going to select this edge here. And I'm going to extrude this one straight up in the Z direction like this, just so it's pretty big. And then I'm going to take this edge here and let's Shift B. Whoops. Control B for bevel, and add a few bevels in here like this. You can make it pretty big. That's fine. And then this is then like becomes your white seamless backdrop. And we can that's why we can make it as big as we want. Make it huge. Even scale it like this if you really wanted to. And then, of course, right-click and shade smooth, so you don't see those bumps back there. We maybe didn't want it to be that big, because you'll still have to light it a little bit. So let's go to render preview. So yes, so render preview. We can see that now we're getting our lighting off a little bit. So I'm going to add just a little bit of lighting here. I'm actually going to remove my point light, and I'm going to add my personal favorite, a few area lights. So I'm going to go Shift A, light, area light. And we need this to be, 1,000 watts. Let's move it like this. Let's just try to point it here. So this, this might be an opportunity to do like some sunlight too. So we could do like Shift A, sun, and point it at the backdrop, so the backdrop's pretty evenly lit like this. Turn the strength up a little bit too. And really, like if you do sunlight like this is enough to light your scene. But it is like sometimes interesting to have. You can use these area lights like as reflection too. So actually, you can kind of see that as I get in the right angle here, you can see that it starts to like reflect on here like this. So that's kind of cool. And casting shadows and obviously things like that. Okay, so now here's turning point. This is where I say, okay, I want to actually like do some really interesting lighting. What does my render look like here? Camera looks up, but like this, the shadows here are trash. So I want to switch over to the cycles renderer. So here we go. Render properties, render engine. Right now it's Eevee. I'm gonna switch it to cycles. Now, you can see that it looks different. And you can see that my recording probably slowed down a little bit. So right here, render engine cycles, feature set supported, device, CPU. So right now it is using my processor to calculate this. Same as it was in Eevee, but cycles is much more demanding on the system. And so because it's doing ray tracing, it's like actually calculating where the light is going, where it's bouncing, where it's reflecting, how the shadows look, etc. So if you have a GPU, you can change the device from CPU to GPU compute. and it may need to redo it. But you can actually see that it went much faster, and now my recording looks a little bit better because the program I use to record my lectures also uses my CPU. So if it's trying to do this, do cycles and record my lecture, it's taxed on my system. But I have a fairly decent graphics card that I use. And when you switch over to cycles, you may need to adjust your lighting a little bit. So I'm noticing that my sun is actually probably too bright now, so I may bring the brightness of my sun down a little bit. And one thing, actually, what if I just do one? What does it look like there? Yeah, that's maybe a little bit too dim. One thing that you'll see is that like when I move around or when I adjust, it gets really noisy, and then it kind of slowly removes some of the noise. And so that's because how Blender is doing this is it kind of generalizes how it'll look, and then it slowly kind of calculates more and more detail as you let it sit. So back to my scene or my render properties here. So we're using cycles. I'm able to do GPU compute. You may not have this option available, and that's fine, but it just may be a little bit slower. So I encourage you to test with cycles, play with cycles, see how your computer does with it. And if you need to use Eevee, that's fine too. Eevee works just fine. One thing that we can look at, if we go into edit menu and go to preferences here, on the system tab, there's this drop down here that has cycles render devices. So there's none. CUDA is a NVIDIA, not property, but it's an NVIDIA system. There's CUDA cores and NVIDIA graphics processors that work well with cycles. Optics is another NVIDIA thing, but HIP is for AMD. So because I don't have an NVIDIA graphics card, those don't show up for me. But because I have a AMD graphics card, you can see I have a RX 5600 XT, and I also have an AMD processor. I can signal like, yes, when I want to render with cycles, I want to do GPU compute, and I want to use my graphics card, my 5600 XT. I bought it right before the shortage. I lucked out. Cool. And so, then we're doing much better. Okay, let's look at this a little bit. So I just want to play with a couple of things here in cycles and render out an image, just so you can kind of see what's cool about it. Let's say I actually don't want a shadow, or actually let's turn off the sun. Don't want the sun. And let's analyze the shadows a little bit here. So you can see that the shadows are much more realistic here with cycles. That, yes, it's calculating because I'm using an area light. It's a little bit wider, so the shadow kind of comes together a little bit. Like it's darker and more condensed here, but then as we get further away, you can see that there's kind of like a triangle that's forming. But then the other parts are kind of being scattered outward like this, so it's not a very harsh shadow. And like all of these things you can play with in your light properties. So like you can change the size so it's a more diffuse light, or you can make it smaller so it casts a harder shadow. You can have it not cast shadows if you want to be fun like that. Rectangle, we can change our rectangle properties a little bit. I just like area lights, because I don't know, it just like reminds me of being in a studio. My dad was a freelance photographer for like 30 years and had his own photo studio, so I kind of grew up around studio lights and stuff. What else can we do? Let's look at our camera. So actually what I want to do is I want to find like a really interesting camera angle for us to render at. So I'm going to imagine this phone like floating a little bit. So I'm actually going to GZ move my backdrop down a little bit. And I'm going to add in some more aerial lights. And so like my scale is a little off here. So maybe I even like just like move this in a little. So we're actually kind of casting light on the backdrop. And I'm just going to add in a bunch of lights. And I'm going to up the wattage. So let's make this 5,000. Not 500, 5,000. Is this going to be too much? Probably not. Oops. And I'm going to shift D to duplicate this light, move it over here, and just kind of turn it this way. So our lights are kind of pointing at the backdrop. Can I make my back? I'm going to change the name of this plane to backdrop. Can I make this my backdrop? Where's my material on here? Oh, I don't have a material on here. That's why I was like, it's looking really gray. Let's add a new material on here. Make this bright white. There we go. There we go. Base color. Cool. Turn down specular. Turn down roughness. No, doesn't matter. Just so, because I want it to be I want it to be white. Okay. Sorry. And I'm gonna Shift D, add one more. Right over here. And have this one kind of pointed at towards the phone a little bit. And then I want to have my camera be kind of dead center like this. Control Alt 0. And I'll Shift D, move my camera. I'll have my camera selected. GZ, move it like this. Okay, and now I want to like rotate it a little bit. I'm gonna get out my rotation tools actually, because I want to rotate it until I get a little bit of like reflection in the phone of one of the lights. Oh, whoa. Okay, so there was one. I'm gonna change my default orientation to local. I want to rotate just a little bit like this, maybe. Actually, you know what might be better is if we get like a little bit of shine on the phone now. So the other thing we can do, I'm going to go to my camera. I'm going to change my focal length to something a little bit more exciting like this, like a 120. Sure. All right, I'm going to get it out of my view here. And I'm going to add in one more aerial light. I'm going to Shift D, select this light, Shift D, duplicate it. And I'm going to get my material or my transform properties like this. And I want to try to, just add this one into the reflection if I can. I have to like do a little bit of guessing because it's like, okay, if my camera's looking here, you know, the light's going to have to be like over here or something. So maybe I just make it really big like this and see if the phone can catch its reflection. And maybe it has to be like way up here. Maybe I'll just rotate it this way. Right? Like what's a good way to calculate that bounce? It's probably got to be over here even more. Oh no, yeah. It might even have to be like back a little bit. Let's rotate our phone again to see if we can catch the reflection. Oh, here we go. Here we go. There it is. Okay, just so that we get like a little bit of reflection on part of it. And actually, you know what? That might even be the backdrop reflecting. Anyway, I kind of want it to be like at an angle like this. That's fine. I want it to be at an even crazier angle. Oh, here we go. There it is. There it is. Okay, that's the shot I'm looking for. Boom. Perfect. Okay. because I just want to see some of the reflection of the light in there. Great. All right. So one other thing I want to show you that's cool about using the cycles render is doing depth of field. So if you've used a DSLR camera, or like maybe even smartphones can do things like this these days, but you can have a really shallow depth of field. So you can have your background way out of focus and your foreground way out of focus, and like have a very set distance, focal length. No, not focal length, but a very set distance that things are in focus. So let's look at our camera. And down here on our object data properties, we want to enable depth of field. So you can see when I click depth of field, it gets a little bit blurry. And we have a couple of options here. F-stop is also is the measurement of the opening of the aperture in a camera lens. So like this is actually kind of simulating a real camera here. And we can set so right now the focus distance, the distance that is in focus is at 10 meters from the camera. So since I have no idea how far away this phone is from the camera, we can actually just set a focus object and say, hey, focus on phone. And so it does it on the center of the phone. So you can see if I crank down the f-stop, it continues to make it more blurry. So like f-stop 0.09, you can see that like the front of the phone is a little bit blurry, the back of the phone is a little bit blurry, but it's sharp in the middle. So you can even crank this down to like 0.001, and you can see that there's just a tiny bit. So this is ridiculous. I mean, like I don't know if there are camera lenses that exist that are 0.01 f-stop. So we can open it up to a little bit more, or close it down to a little bit more of a realistic number. 0.9 seems to work fine. Now the other cool thing you can do, I'm going to get out of my camera view for a second, is you can set a null object as your focus object too. So like I could go Shift A, add an empty plane axes, and I can move this up, and maybe I'll call this empty like focus point. And I can, if I go back to my camera view, I can hit the button here. And select my camera, go to my camera, object data properties, and rather than have phone as my focus object, I can have this focus point as my focus object. And so then I can even like say exactly where it's like, okay, I want G, what axis is this? X, come forward a little bit. I want just this very front corner of the phone to be in focus, GX. So you can see that like, yes, it's focusing exactly on this point. And so like the front corner of the phone's in focus, but the back is out of focus. Cool. Or, I'll move this back a little bit. GX, go back. Cool. Was that too far? Yes. I want it to be pretty much right in the middle of the phone right there. 0. Okay. Cool. Let's do a render. I'll do a quick render. I believe it's just F12. It gives me a nice render here. So with cycles, it's pretty much going to go as long as it can, because like the longer that it renders, the more samples it's taking of the scene, and the more detailed it's going to be. So the longer you let it sit, the better render it's going to be. Obviously you can and probably should set limits. So like here it's saying, if you look at these numbers along the top, it's doing 1 frame, and it's up to sample number 400 out of 4,000. It's got about 6 minutes left on this one image. And that's probably too much. You probably don't want it to go that long. I'd say it's already got enough detail just as is here. So I'm going to close this and cancel it. Let's go back to render properties. So here, we've got sampling. Sampling is like how many times it's gonna render, or how many times it's gonna try to do the math to calculate how much detail is in this image. And so there's two options. There's a viewport and there's render. And so viewport is how we're viewing it in here. Render is obviously what it'll look like in the render. And you can see there's a couple of differences. In viewport, denoise is turned off. So all these little like speckles that you see are noise. So it's not denoising here in the viewport. So if I check that, it's actually going to attempt to denoise here in the viewport, but you can probably just leave that off. You can see all the little noise comes back. But you do want to try to denoise in the in your renders, because it'll look a little crisper, a little nicer. Noise threshold. I mean, these are things to play with. But max samples. So you saw that it was going to sample it 4,096 times, and it was going to take 6 minutes to do it for one still image. And maybe you're fine with that amount. There's definitely diminishing returns. So like honestly, like start with something like 120 even. You can also set a time limit. So if it's at 0 seconds, it's just going to go as long as it wants. Or you can say, you know what, don't spend more than 60 seconds or 1 minute, I guess, on here. So like let's try it now. So I have it set to max samples of 120. Let's see what that looks like. I go F12. So it's calculating, doing the math. So you can see it, we're already at 49. That's looking pretty good. 65, 80, 96. Cool. There we go. Done. So, that took 16 seconds. I'd say it looks pretty darn good. Maybe you wanted to go a little bit more. Maybe you cook this up to 200 or something like that. Whatever you're comfortable with. And then of course we can save this image as like Nolan's sweet phone. Nolan's sweet phone. I'm in the market for a new phone. Not in documents. My documents folder. I'll save in 2022. Spring 2022. Okay. Yeah, so Cycles is just a little bit cooler. But there's no shame in using Eevee. Obviously, it requires a little bit more computing power to use Cycles, but that's how you get the good stuff. I believe next week, I'm going to talk about some advanced lighting, some cool lighting things that you can do with Cycles. We'll talk about using HDRIs and using kind of environment lighting and things like that to kind of go along with your assignment 5. But that's it for this week. Please don't forget to work on your assignment 4, which is your movie studio graphic logo animation type thing. Next time we Zoom, so next week we'll do a progress check on that. Please email me if you have any questions, and happy rendering and animating. Goodbye.